Welcome next, Tyler Alvarado, presenting Continuous Composites.
Thank you, Lauren. This carbon fiber bike, the Koenigsegg, Boeing 787 Dreamliner, or Arkema's carbon fiber Grand Prix racing yacht. What do all these applications have in common besides costing a fortune? They're all manufactured using advanced composite materials. The key to composites is lightweighting the part, which enables them to be fuel efficient and carry higher payloads. Composites are superior from a strength to weight ratio compared to metals and other plastics. They have a low coefficient of thermal expansion and they're non-corrosive. So why do we only find composites in high-end applications like these? The answer is found in the constraints that most traditional processes are burdened with. There's an extensive amount of skilled labor required. There's always expensive tooling and molds that have to be manufactured ahead of building the part. There's expensive capital equipment like ovens and autoclaves and a high amount of waste. All of these constraints lead to a very high cost to manufacture that finished component. There's very long lead times, and if you want to change designs, you got to completely retool, which slows down that design iteration process. At Continuous Composites, we are introducing the next generation of composites manufacturing. This right here is our patented continuous fiber 3D printing technology known as CF3D. We are combining the power of these composite materials like carbon and glass, leveraging additive manufacturing and robotics. This is a fundamental shift in the way you manufacture composites, resulting in a moldless and out of autoclave composite manufacturing process. We can steer fibers in all three dimensions, which allows us to truly leverage the anisotropic properties of a continuous fiber. This opens up design possibilities, enables complex organic geometries to now be manufactured using these high performance materials, which weren't manufacturable before. In addition to that, we can integrate functional fibers into the structure. We are developing not only structural solutions, but we are developing material combinations for very high temperature applications like carbon bonded carbon and ceramic matrix composites. Our process begins with a dry continuous fiber, which could be anything from carbon, glass, Kevlar, or ultra high molecular weight polyethylene, or maybe it's a functional continuous fiber. That dry fiber is brought into our impregnation module where we impregnate it with these snap curing thermoset resins. And then our proprietary software moves the print head around, discharging the material, where we mechanically consolidate it and cure it right after the point of discharge, enabling that composite structure to take its shape right in front of the user. Our business model is one solution. We're offering hardware, software, and materials, which includes end effectors, best-in-class motion platforms, and numeric controls. Our software enables these complex geometries to be manufactured, and then we are developing a library of material combinations that meet high demanding mechanical properties from various industries. Additionally, we are setting up a division as a service bureau to manufacture high value, lower volume parts, including ceramic matrix composites and carbon bonded carbon composites, as well as licensing our extensive patent portfolio to non-competitive applications. Since our inception in 2015, we have raised over $8 million of equity capital, which we have used to reinvest in advancing the technology and expanding our IP portfolio. We have formed strategic partnerships in all three of the technical domain areas. In addition to that, we have engaged with strategic customers as industry leaders in their respective industries, developing the technology for their applications. And we do that through funded NRE projects, which are not only non-dilutive to our business, but they also ensure that our development efforts are very focused on real industrial applications that are usable in today's market. Primarily, we've been focused in aerospace, defense, and energy, because those are the industries that already manufacture with composites and understand the huge value proposition that CF3D offers. But we are developing an enabling solution that is directly transferable to every other industry. A couple of the applications we're able to speak about, which are in the public domain, is we have printed a primary structure for Lockheed Martin for an unmanned aircraft system. We've engaged very closely with the Air Force Research Lab as part of their low-cost attritable aircraft technology. And then we have been developing CF3D for a high-temperature application for Siemens' next generation of innovative generators. From a competition perspective, there are a few players like Arrivo, Markforged, and Isoprint. On the surface, their technology sounds like it rhymes with our patented continuous fiber 3D printing technology, but there are some pretty key technology differentiators. We are the only company manufacturing a process that uses snap curing thermoset resins, which offer a huge benefit in industry applications. Additionally, we own the earliest and broadest patent portfolio as it relates to continuous fiber 3D printing. In the graph in the upper right, you can see by company the number of patent assets that they hold, which our foundational IP is being cited against as prior art. We own over 50 granted patents in the US on this technology, with the earliest in the world dating back to 2012, as well as 132 pending non-provisional applications. We have an extensive international portfolio of 61 PCTs, and we're currently sitting at 27 internationally granted patents, covering everything from the process of continuous fiber 3D printing, along with everything else that makes it work, including hardware, software, materials, and beyond. Our go-to-market strategy is that we are going to be transferring a half a dozen machines with our strategic pilot customers in 2021, where our engineering teams will be collaborating to further refine one solution for their market applications. And we'll be taking that refinement and offering that in our commercialization launch in 2022. Our team is comprised of about 25 business and engineering professionals with very relevant experience in automated fiber placement, software, traditional composites manufacturing, as well as an extensive patent team. And then we also have a comprehensive business team. From a technology readiness perspective, we're sitting at about a TRL of a 5, but it really is material specific. This is a snapshot of our TRL as it relates to CFRP, or carbon fiber reinforced plastics, where our goal is to achieve at least 60% fiber volume fraction at less than 2% voids. And I'm pleased to let you know that we have achieved 60.2 fiber volume fraction at less than 0.2% voids. And this was done with our high temperature resin that has a glass transition temperature of 227 degrees Celsius. Thank you so much for your time today tuning into this demo days. I look forward to chatting with you in our virtual booth after this demo day presentation. If you're unable to stick around, please jot down our contact information, reach out to us. We'd love to have a one-on-one with you. And I also wanted to let you know that this presentation will be available for download in our virtual booth. Thank you so much and have a great day.